forward to this. I know you really want me to tell you what's in the box. Don't worry, we do have something big to show you. But before we get into it, I want to give you some updates about our company that I've never shared publicly before. I'm proud to say Formlabs is the largest professional 3D printing company founded since the 1980s. Our revenues have surpassed $250 million per year, and we're one of the only companies in the space that is both rapidly growing and profitable. More importantly, our customers use their printers a lot. They have printed more than 500 million parts. They also love our products. We have a Net Promoter Score of 60, which means they recommend Formlabs at a similar rate as companies like Apple and Tesla. Formlabs' mission is to build the tools that make it possible for anyone to bring their ideas to life. But we need even more powerful tools that can match your ability to imagine products. Injection molding is incredible. It can produce amazing parts with great surface finish and detail, excellent materials, and at very low cost and volume. But anyone who has tried to make something with injection molding knows that it also really sucks. Consider the humble Form 4 mixer latch. It took us 3 months of tooling iterations and thousands of dollars to produce. Why? There must be a better way. We made progress on fixing this with SLA. It's now cost competitive, up to around 10,000 parts, while maintaining the ability to quickly iterate on your design. And we've closed the gap considerably on materials. Take Ali Syed, an amazing product designer who's using Tough 2000 resin for his lightweight gaming mouse to boost durability and performance. He's printed thousands of this design and shipped them around the world. Our latest generation Tough resins have made a huge leap. Usage has more than doubled already in just a few months. But for many applications, we're still not there. Sometimes you need the excellent mechanical properties and geometry flexibility of SLS 3D printing. It's amazing. It has no support structures. But if you want something like the Fuse X1 that can make bigger parts and higher volumes, it would cost you $500,000. So not that many people have access to this capability. All of that changes today. Now let's see what's in the box.
I am incredibly excited to tell you more about our new SLS printer, the Fuse X1. Starting your first job on an industrial printer is usually a multi-day affair. 30 minutes ago, the Fuse X1 was in a crate. Now it's unpacked and wired, and in just 15 minutes, Peter will have it ready for its first print. He's rolled it through the door and into position, and you'll start with raising and leveling the printer. Now, let's back up a little bit. The Fuse 1 series was our first foray into SLS, and it dominates the market today in units sold. But our thousands of successful customers have one consistent request: make it bigger. And today, we've delivered, and so much more. We've gone way beyond big. The X1's build volume is huge. It delivers the lowest part cost in the industry. It redefines productivity. It's intuitive, like any Formlabs product, and extraordinarily reliable. Let's talk big. Support-free printing lets you take full advantage of the Fuse X1's massive build volume. That means you can print large, full-scale parts in a build volume nearly 8 times larger than the Fuse 1 Plus, and dense production batches in the thousands. Let me give you a few examples. Take this huge fixed-wing drone. On any other printer, this would have taken 5 or 6 builds. On the Fuse X1, just one. A 1.5 meter wingspan and every part required can be packed and printed in a single build in less than 24 hours. Same goes for this massive intake manifold. The Fuse X1's ability to produce exceptionally high-quality, dimensionally accurate parts like these is why Radio Flyer chose it to develop their latest e-bike.
The Loop cargo bike is the most approachable compact cargo bike for families. Our frame is totally custom, our accessories are totally custom, and very intentionally designed. Going back a couple of years, we would have built a full cargo bike with a welded metal frame and then clad it with printed parts. We might split it up into about 19 different builds for something like the Loop. That whole process could have taken us 1 to 2 months. With Fuse X1, we could print an entire Loop cargo bike overnight and be gluing it together the next day. So we went from 2 months to a couple of days. I can iterate 3 times as often with 9 times less labor. That's a super appealing value proposition.
Radio Flyer has gone from waiting days or weeks to iterating overnight. They're now shipping more products to market faster than ever thanks to the Fuse X1. But a larger printer doesn't just mean big parts fast. The Fuse X1 sets a new benchmark for productivity. It can reliably print builds so dense that legacy systems will outright fail or produce unusable parts. We achieve this with a technology called adaptive thermal control. With 13 independent thermal zones using 700 times more thermal data than the Fuse 1 Plus, the Fuse X1 delivers, maintains, and sinters powder at an incredibly stable temperature, giving you unlimited freedom and exceptional part quality. Take this Form 4 mixer latch. In a Fuse 1 Plus, I can fit about 300 in a build. On a legacy industrial printer, about 800. But the X1, it can reliably fit over 3,000 in a single job and 10,000 in a single week. As you can see, the X1's build volume is not only larger, but thanks to adaptive thermal control, we can also pack parts closer together and without restrictions on the orientation or the placement in the build. That means you have nearly unlimited packing density. Productivity like this is changing how the world's most advanced companies develop products and solve problems. And if there's one company that you can count on to push the boundaries of manufacturing, it's Tesla.
Here at Tesla, we make progress on new projects faster than seems possible. We set impossible deadlines and then somehow meet them. Having in-house additive allows us to print a part, test it, break it, find out what's wrong, print it again with a new design over and over until we get it right. So due to the print speed, the Fuse X1 allows us to use the entire build volume within that 24-hour build cadence, which effectively doubles the volume compared to our legacy SLS printers. Yeah, and then on top of that, the reduction in manual labor. Fuse X1 really allows us to run high mix builds with starkly contrasting geometry. So you can have one very large part surrounded by a bunch of little parts with minimal or no impact to the quality of the parts coming out at a very high packing density. With this non-marring shim, we had looked into injection molding and had found that with the SLS systems, the cost per part was competitive enough that getting a mold made really didn't make sense, even though we are going through 10 to 20,000 of these a month. Yet with the increased throughput and decreased cost, it has completely changed our perspective on what kinds of projects our lab can support versus what we would have traditionally moved to an injection mold.
Innovators like Tesla can now move even faster thanks to the sheer productivity of Fuse X1. At this point, the machine's been raised up off its wheels, and now Peter's finishing up leveling the Fuse X1. Throughput only matters if the parts are usable. The Fuse X1 consistently produces exceptional parts, more reliably than any SLS printer on the market. Thanks to our new AI-powered print failure prevention system, Print Intelligence. Print Intelligence detects part defects in real time. The failure is isolated and selectively removed from the following layers. The rest of your parts print as normal, so you get great parts on time, every time. The Fuse X1 can produce 4 times more parts per build than a legacy industrial printer. all while occupying less than half the floor space. This breakthrough productivity and reliability makes the Fuse X1 the most profitable SLS printer ever developed. For the last 4 months, Additive Manufacturing has been using the Fuse X1 to deliver thousands of parts to customers all around the country.
The Fuse X1, it's our 5th SLS machine and by far the most productive. The sheer speed is extremely impressive. It requires very little floor space compared to our other industrial SLS machines. And yet, on a dense build, it delivers more than double the throughput. Other service bureaus running legacy platforms are stuck with build times that are 2 to 3 times as long. The Fuse X1 is able to deliver its massive build volume every 24 hours. This means that you're able to produce giant parts, thousands of small parts in a single build every single day. It's a game changer for the industry.
Our customers are proof that the Fuse X1 is the most productive, reliable, large format SLS printer ever designed. But we didn't stop there. The Fuse X1 runs on single-phase power, fits through a standard door, and requires 0 facility retrofit. Print changeovers take 5 minutes or less, meaning no dedicated operators are required. It all starts in Preform, our industry-leading print preparation software. Industrial printer customers pay tens of thousands of dollars every year to start a print. Preform is free. Packing and part orientation can be handled with a single click, and jobs can be easily sent to the printer over a network connection. Looks like Peter's finished the final setup and the printer's powered on and ready to go. All that we need now is a build unit to start our first print. Thanks, Peter. Now we have everything we need to start our first print. We'll take this clean build unit and just roll it in. It's easy and intuitive with a quick connect interface. We load material with the automatic powder transport system, which conveys material to the hopper. Integrated powder sensing will monitor your material level while the hopper continues to fill during the printer's startup routine. From here, I can just press print. Today, we're also introducing the Fuse X1, redesigned from the ground up to handle back-to-back massive builds without constraining your throughput. It's high capacity, fast to break out, and clean for maximum production efficiency. Part cleaning and polishing is still handled automatically by the Fuse Blast, now featuring a 50% larger basket, easily removable to manually clean large parts. From design to finished part, no dedicated operator, no specialized training, and virtually no downtime between prints. This is the Fuse X1. So, what does this all come out to? If you wanted to print over 10,000 parts a week, and you also wanted to print a performance nylon part that's over 500 millimeters in length, what would that cost you today? These capabilities from any other vendor would cost you over $1 million. But our mission is to build the tools that help anyone bring their ideas to life. So, the Fuse X1 starts at $85,000. In the last 4 months, our customers have printed over 30,000 parts using Fuse X1s, and new deliveries will begin in Q4 of this year. Nylon 12 will be available on day 1, with Nylon 11, Nylon 12 glass-filled, and TPU coming soon. The Fuse X1 is going to redefine manufacturing. And with that, I'll hand it off to Sharon Sung, our Head of Materials Development, who will tell you about an exciting new SLA material.
I'm excited to share an advancement in our SLA portfolio that stretches what additive manufacturing can do. As Max mentioned, we've made huge progress in our tough materials, bringing SLA resins one step closer to matching the properties and performance of injection molded plastics. However, with 3D printed elastomers, you still face a hard choice. If you have used 3D printed elastomers, you will know that most of them lack tear strength or resilience. Others are impossible to print complex geometries or expire within a day once you start using it. No 3D printed material today has a good combination of performance, printability, and easy workflow. This is why we're announcing the new Flexible ADA resin. Flexible ADA resin is a resilient elastomer that matches the look, feel, and function of a cast or injection molded urethane. Let's do a little performance comparison by testing some 3D printed bouncy balls. I have 2 balls printed in popular flexible materials. On the left is the old flexible ADA resin, and on the right is a TPU ball from a FDM printer. That was pretty sad. Neither of these bounce like you would expect from a real elastomer because they have poor rebound and energy return. These materials do not effectively simulate conventional elastomers, making them a poor choice even for prototyping. Now let's compare the new flexible ADA resin to a performance benchmark, an off-the-shelf urethane ball. With a 56% rebound, the new material's resilience can actually exceed many cast urethanes. But printing or casting a ball is easy. With the new flexible ADA, you can easily create aesthetic, functional parts in any geometry, not possible before with a single part 3D printed elastomer. Like this dust blower that was completely non-functional in flexible ADA V1. In the new flexible ADA, it snaps back to shape in an instant. Or this full-size airless football that can be printed without any internal supports. Or complex contour parts like these goggles. But those parts are only useful if they're strong enough for their applications. To test how strong the new flexible ADA resin is, we printed this swing on a Form 4L. Let's put it to the real test. As you can see, flexible ADA resin is strong enough to hold me. Elastomers, however, are commonly manufactured using a lattice design to use less material and reduce weight. So let's raise the stake by trying a lattice swing that is only 6 millimeters thick. The new flexible ADA resin is available now on all Form 4 generation printers, and I cannot wait to see what ideas this material can help bring to life. And with that, I will hand it back to Max.
With the launch of the Fuse X1 and the new flexible ADA resin, we are making 3D printing competitive with injection molding for a much wider range of applications. I know we have something special with the Fuse X1. It's the biggest step towards our mission that we've made so far. Tools that can finally match your ability to imagine products. Let's go make something big.